All right, section 9.2, performance factors. What can degrade performance, right? So what can happen to our drone that will make it not fly as well? The term used by the FAA, they'll see this term density altitude. Whenever they're talking about, degrading something, degrading the density, altitude, or performance, this is what they're talking about. Low density altitude refers to density at low altitudes, and high density altitude refers to density at high altitude. So if you're up flying in the mountains in Denver, Colorado, you got to think about there's thinner air, and you got to deal with that. But understand that's what it's about. It's about thin air, whether you're flying at sea level or a mile up. But this is the part to remember: when density altitude goes up, performance goes down. That's the part where you might get a question and you're like, I don't really understand what they're talking about, density altitude. When density altitude goes up, performance goes down. Okay. What can degrade performance? Altitude, right? We just talked about that. Density, altitude. Less air, thinner air at higher altitudes. As that goes up, performance goes down. Think sea level versus Denver thin air. Temperature can matter, right? Whether it's cold, you've got, ice forming on wings. You've got the thickness of the air because of the humidity, surface slope, surface winds. How is the wind impacting and blowing into your environment, whether you got buildings around you or, we talked about that in flight environment, obstacles, building in mountains, weight. As you increase your weight, that will affect your drone. As we know, this is pretty obvious stuff, but really any change will degrade performance. That's how they look at it. This is what the FAA is after. Like, what they're saying is, if you mess around with your drone, you got to be careful. Like, your risk has gone up. Deal with it. Weight is important, right? Both in terms of, you got a heavier drone, you loaded something up to it on it, like, it's not going to fly as well, and your flight time will be reduced, right? So you throw a GoPro underneath your drone, like that half an hour that you had may turn into 20 minutes, right? Your climb rate is reduced. You can't shoot the drone up as fast as you want. Stability is reduced. It's going to wobble more and be out of balance more. Acceleration is reduced. If you try to shoot the drone forward, it's just not going to happen as fast because it's heavier. It makes sense. And your maximum altitude is reduced as well. You can't go up as high. I mean, theoretically, you're still going to get to 400 feet, but just understand that the heavier things are, it's going to dull everything down and make things more difficult. Excess wind can multiply this effect, and increasing your load factor can multiply this as well. So you got a lot of wind blowing, and it's a heavy drone, like, it's really going to be like stuck in a swamp. What effect does high density altitude have on the efficiency of a UA propeller? High density altitude. When in doubt, choose the answer that says decreased, unless you're sure that it's the other way. Almost always it's going to be, when something's going to get degraded. So propeller efficiency is increased when high density altitude when it changes, or propeller efficiency is decreased. That's kind of more what we're expecting. Or C, density altitude does not affect propeller efficiency. Always go with the, safe answer, right? Which is B here. All right, and last lecture on load factors in section 9.